All right, section 1.5. Definitely changing gears a little bit coming out of the first four sections. Those first four sections really tied together nicely, didn't they? So, a little big picture perspective, those four sections definitely went together. And obviously, we're still talking about trigonometry, but we're definitely changing gears a little bit, and now we're going to be looking at graphing trig functions. You got to remember what a function basically means. One way to describe a function, what it is that now we're involving two variables, x and y. So look at this equation involving both x and y, and now that means we can kind of graph it in the xy plane. So let's say we wanted to graph the following function, y equals the sine of x. Okay, what is that graph going to look like, do you think? So like you've no doubt done in the past when working with new and unfamiliar functions, we're going to build this graph, okay, by generating an adequate number of what? So think about that. In the past, when a teacher threw a crazy, weird-looking equation at you and said, graph it, what was maybe the first method that you guys did when working with a new kind of equation? Did you just generate a bunch of solutions? Probably. And that's what we're going to do here. We're going to generate an adequate number of solutions to the equation and use those solutions to come up with the graph. Now, for a second, let's think about what kind of values that we're going to plug in for x. Because remember, you might remember this as we're going to make a table of values. And oftentimes you have to pick values to plug in for x and get all those corresponding y values. So what kind of values are we going to plug in for x? Now remember, sine of x, the sine of what? We're going to be plugging in basically angles. So I guess what I'm saying is, should we be plugging x values in there in degree form or radian form, right? Think about that for a second. Would it make much sense to plug in degree values, right? Because theoretically, you don't need to write this down, but if we were to plug in 30 degrees for x, what would that make y? That would make y the sine of 30, which is 1/2, right? So that would generate the solution 30 degrees, comma 1/2. So I ask you now, where is that point on the xy plane? Where is 30 degrees on the x-axis? Right? So, I don't know. I do know, but it's not, like, the x-axis is not really in degrees. So that basically leaves radians, So again, the x-axis, it makes more sense to think of those values being in radian form than degree form. So we're actually going to be working with radians as we graph these things, okay? So we should probably be plugging in x values that are in radian form. So what if we plugged in the following value for x? Let's say we plugged in pi, right, which you should know is equivalent to 180 degrees. But what if we plugged in pi for x? What would y be? Well, again, from the equation, y equals the sine of x, that would be y equals the sine of pi. And what is the sine of pi? Which again is equivalent to sine of 180. Wouldn't that be 0? So the sine of pi, you'd get 0. So that means the following point, like I hinted at a minute ago, would be on our graph. Pi, comma, 0. Right? Now, right away, let me kind of say, we could figure out where this point is. Because remember, pi is basically what? Pi is, again, 3.14. Don't forget that, especially in this lesson. Do not forget that pi is basically the approximately 3.14. So, like if I said, hey, everyone, graph the point 3.14, comma 0, you could totally do it. Anyway, moving on to the next point. So pi comma 0 is going to be on the graph, and so would all of these, right? Like if we plugged in 0 for x, wouldn't we get y equals the sine of 0, 0? So 0, 0 is going to be on our graph. It's going to be a point on our graph. How about pi over 2, which is essentially 90 degrees? If we plug that in for x, y equals the sine of pi over 2, wouldn't that be 1? So pi over 2, comma 1 would be on our graph somewhere. How about 3 pi over 2? You guys remember 3 pi over 2 is basically 270 degrees. So, right? And, you know, many, 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 many more. But so all these points would be on the graph. Now, the next thing I want you guys to do in a moment, right? When I say so, I'd like you to, because this is what we did in class, right? I want you to, or this is what we're doing in class. Like you might be watching this video because you missed class where we did this. But so in class, we're going to kind of have you fill out these tables on your own and try to sketch together the graphs on your own here. So in a minute, I'm going to have you pause the video and try to finish these graphs. But before we do that, let me point out a few things. So you should have a paper somewhere, whether it's the back of a page or a different page altogether. You should have these tables that need filled out, and you should have these graphs for sine, cosine, and tangent. So more specifically, y equals the sine of x, y equals the cosine of x, and y equals the tangent of x. So, the idea is to fill out these tables. Now, just to kind of make sure I'm thorough here, plugging in 0, pi over 6. Pi over 6 is essentially 30 degrees, right? But it's just, we're working in radians, right? Pi over 3 is 60 degrees, essentially. Pi over 2 is 90, and so on and so forth, right? So you're going to be plugging in all of these values. And you can essentially, if you have a calculator handy, you could just let the calculator bang these out for you. Just make sure that if you're going to be plugging in these values, right, if you're going to be doing the sine of pi over 6, make sure that, for one, pi over 6 is in parentheses, you know, and make sure your calculator is in radian mode. Okay? So you're going to probably just let the calculator just, you know, bang these out for you. But to actually graph these, you know, like for example, when you plug in pi over 3 for a sine, you're going to get that, or you might get just root 3 over 2. Yeah. So you don't have to write all these down, but so essentially, you're going to have a point of pi over 3, and for at least here, I'm going to write it as root 3 over 2. But when you go to actually graph this, like where is this point? Where is pi over 3? And where exactly is, root 3 over 2? Well, the root 3 over 2 part, you might as well just go ahead and approximate that decimal, because it's going to be much easier to sketch where, the y-coordinate of 0.866 is than root 3 over 2. So you want to probably have these all in decimal form, okay? And concerning, where pi over 3 is, yeah, I guess you could just do 3.14 divided by 3, and get 1 point something. But here's what I'm going to point out. Over here in parentheses for most of these, like for 0, I say that it's basically 0 pi over 6. Pi over 6 is basically 1 pi over 6. Pi over 3 is equivalent to 2 pi over 6. Pi over 2 is equivalent to 3 pi over 6. And why am I doing this? Why am I writing, what these all are in sixths, right? Well, if you go back to the graphs, okay, if you look over here, I've already divided the axis up basically by sixths of pi, okay? So here's pi over 2. Now again, this is something huge to say as I point out, how I'm labeling the x-axis. Normally when you graph something, you label the x-axis 1, 2, 3, 4, but I don't know, we could do that, I guess, but wouldn't it make a lot more sense to label the x-axis and break it up in terms of pi? So like here's pi over 2, here's 3 pi over 2, and if you notice these little notches, what I essentially did is broke up pi in sixths, right? So this right here, this would be like 1/6 of pi, or pi over 6. This is 2/6 of pi, which is 2 pi over 6, or in other words, pi over 3. This is 3/6 of pi, in other words, pi over 2. And so on. 4 pi over 6, which is 2 pi over 3. 5 pi over 6, and this is 6 pi over 6, which is just pi. Okay? So that's going to help, right? So, for example, when we go to plot this, 1 pi over 3, this is essentially 2 pi over 6, comma 0.866. So we're going to have a point at 2/6 of pi, 0.866. So that would be here. And where do you think 0.866 is about? Don't feel like you got to be super duper perfect. Let's say it's there. So this is essentially pi over 3, comma 0.866. All right. So there you go. All right. So now, please pause the video and see if you can complete. Just for now, just do the first two tables for sine and cosine. All right. See if you can complete those tables on your own. All right, so hopefully by now you've attempted to do this on your own. Again, just letting the calculator bang them out and see if you can plot all these points on the graph yourself. So let's see how you did. So the sine of 0 would be 0. So that means 0, comma 0 is on the graph. All right. Pi over 6, which is like 30 degrees. Would get you 0.5. So we have pi over 6, comma 0.5, which is like right there. Pi over 2, the sine of pi over 2 gets you 1. So right about there for pi over 2 comma 1, those coordinates. If we plug in 2 pi over 3, we get that. And so that gets us that point for the x and y coordinates, right? And so on and so forth, right? So we get that, we get that, we get that, we get that, okay? All the way to when, yep, the sine of 2 pi, which is basically the same as plugging in 0, right? The sine of 0 is the exact same as plugging in 2 pi, sine of 2 pi. And so you're going to get 0. And so the sine graph should play out like this if you got that table right and you are, let's see, there-ish, there-ish, and don't need to be like super perfect, but if we plug in 3 pi over 2, or 3 pi over 2 comma negative 1, so there-ish, and then there, and then here, and then there. Okay, so when you plot all those points, that's what it should basically look like, you know. Now remember, we could have plugged in a lot of other values, right? Like, you know, we could have plugged in, let's see, this is essentially what, 30 degrees, right? That's like 30 degrees. What if we plugged in the radian value for 10 degrees? You know, what if we plugged in this? Like, we'd get a dot somewhere, right? So again, this is not a new concept. It's not just these dots. It's many other dots. So we connect the dots. Okay? And so we get this sine curve. And that's what the sine graph looks like. Now, furthermore, is that all there is to the sine graph? I mean, could we not plug in values out here? Like, could we not plug in, like, this is essentially 360 degrees, right? Couldn't we plug in 390 degrees? Couldn't we plug in 450 degrees? You know, how about over here? Could we not plug in essentially what is negative 90 degrees? Could we not plug in negative 180, right? But here's the thing. Hopefully you understand that once we start going into angles larger than 360, aren't we just kind of repeating the same angles essentially? And if we go to, like, say, negative 90, wouldn't that be the same as positive 270? So again, essentially what I'm saying is, won't these answers, won't this shape just keep repeating itself over and over and over again every time we go through another 360 degrees? Won't this kind of curve just repeat itself? So this just kind of repeats itself, and it'll do it in both directions essentially. So let me throw a vocabulary word at you right now and say that from here to here, or from here to here, whatever, like, this is one period, there it is, the vocab word, of the sine graph, okay? From here to here, for it to do its thing through all the 360 degrees, that is one period of the sine curve. So moving on to cosine. When you plug in 0 for cosine, you get 1. So again, the point 0, 1 should be 0, 1 should be on the cosine graph, and so should all of these. Right? So just a random example, 4 pi over 3, which is essentially 8 pi over 6, okay? would get me negative 0.5. So at 1, 2, 3, 4, 5, 6, 7, 8 pi over 6, like 8/6 of pi, we should be getting about negative 1/2. That's the point, okay? Anyway, here's what the cosine graph should look like. Let's see, the cosine of pi is in fact negative 1, so that makes sense. Bam. 1/2 is the answer there. Here the answer should be like about 0.866. And back to cosine of 2 pi. If we plug in 2 pi, it's just like plugging in 0. So we should get 1. So again, there's an infinite number of points. Like there's a dot here, a dot here, a dot here, a dot here, a dot here. There's a dot here. There, you know, we could plug in any x value we want. And come on. And this is essentially one period of the cosine curve, right? But just like the sine, right, this shape repeats itself over and over again, because once we go further to the right or over here to the left, we're just repeating the same x values, essentially the same angles, you know, thinking about coterminal angles and everything. And we're going to be getting like the same answers. So this shape essentially just repeats itself over and over again. Okay? So now is maybe when you can pause the video again and see what happens when you try to fill out the tangent table and plot all of those points on the tangent graph. All right, just kind of notice that these radian values are a little weird. What you're essentially going to be doing is plugging in these degree values: 0, 90, negative 90, 45, 60, 80, 85, 88, so on and so on. So pause the video and see if you can fill out the table and plot those points correctly, okay? All right, hopefully you've attempted that. And so when you plug in 0 radians, so y equals the tangent of 0, you should get 0. So that means the point 0, 0 should be on our tangent graph, okay? Now, what happened when you plugged in pi over 2? What's the tangent of pi over 2? If you already attempted this, which you should have, your calculator gave you an error. Why did the calculator give you an error? And did you do something wrong, or was that expected to get an error? It was expected, right? And remember that you can't do the tangent of 90, or in other words, the tangent of pi over 2. So basically, the tangent of pi over 2 doesn't exist. And you might have also seen that trying to plug in negative pi over 2, okay? You simply cannot do that, all right? The tangent of negative pi over 2 does not exist. So what does that mean for the graph, right? I mean, look, where would you put the point over here at pi over 2? You know, like you'd be pi over 2 comma does not exist, right? So where would we put that point? Here's the answer. There is no point at this x-coordinate. In fact, what that means is we put something called a vertical asymptote at pi over 2. All right, because there essentially is no graph right here. There is no point, right, for this x-coordinate. There's no y-coordinate for this x-coordinate. So it's kind of like a force field that goes up forever. In fact, what? I totally picked gray. That vertical asymptote goes up forever and down forever. And like I said, there is no point anywhere on this vertical line, right? And it's kind of like a force field. Same thing with negative pi over 2. We have a vertical asymptote over here as well, which is kind of like a force field on the graph. Okay? That's what happens. The rest of the table is going to kind of look like this. So at 45 degrees, which is where? Like if this is 90, so this would be where 45 degrees is, right? And so we'd have a point there, right? So essentially pi over 4, right, comma 1, which is right there. And at negative pi over 4, comma negative 1, right? How about plugging in like pi over 3? We get about 1.732, and likewise at negative pi over 3 or negative 60 we get that. So negative 1.7-ish. Negative 1.7-ish and positive 1.7-ish. And like right, whatever, like right here-ish, maybe. And at negative 60, right here, we get, negative 1.7-ish, whatever. But look what starts happening. If we plug in what's essentially 80 degrees, we get 5.67-ish, right? About 5.7. And if we plugged in negative 80 degrees, or negative 4 pi over 9, we get that. Like negative 5 point, hold on. Gang, can we even, so we go to 80, like where is that? If this is 1, 2, 3, like we're already out of bounds here, man. Wow. So this point's going to be like somewhere up here, and this point for 80 degrees is going to be, out of bounds underneath here. Like what? But then look at the table some more. If we plug in 85 degrees, which is like, right here-ish, right? Like 85 degrees is like right here. We get, now we're at like 11.4, okay? And if I go all the way to 88 degrees, which is like, right there and there somewhere, we get over 28.5, So just for fun right now, if you're still with me, what happens if you plug in 89 degrees, right? What y value do you get? What y coordinate do you get for 89 degrees? So put your calculator back in degrees. What if you plugged in 89.5? In fact, I'm going to do that really quick. Is my calculator in degree mode? Yep. Tangent of 89.5. That's 114.5886, blah, blah, blah. Geez. Anyway, so what's happening here is this. We can plug in numbers that are really close to 90. Guys, we could plug in like 89.999 degrees and just get like a really, really large y coordinate for that. But if we try to go all the way to 90 degrees, that's where all of a sudden there is no dot, because it doesn't exist, and we're not allowed to actually run into this vertical asymptote. So anyway, to finally get to the point, no pun intended, the tangent graph looks like this. And it's just going to kind of creep closer and closer to this vertical asymptote, but never actually touch it. It's a really crazy concept in math where it gets like infinitely close to this vertical asymptote, but like never hits it. It just gets closer and closer and closer and closer forever. And anyway, the rest of the graph, oh man, got to hit those dots a little better. Is just going to do the same thing down here.
Barry, please come to the office.
Anyway, so that's the graph. It kind of curves, you know, and kind of does a little change in the curve right here, okay? And that is one period of the tangent graph. And one more thing to note before I end the video here. Notice that one period of the sine and cosine graphs lasted 360 degrees essentially, or better yet, 2 pi radians. So one period of the sine and cosine was 2 pi. But tangent, what is this?
Chad Fries, please report to the office. Chad Fries, please report to the office.
Man, just like class. Anyway, as I was saying, one period of the tangent curve goes from, for example, in this period, negative 90 to 90. That's not a full 2 pi. That's just 180 degrees, you know. So basically, every 180 degrees, or in other words, every pi radians, the tangent curve is going to repeat itself. Okay, so there's another period of the tangent graph. Let's see. Right here. Wait. Another pi would be here. So there'd actually be yet another. Why am I doing this with the mouse? There'd be another vertical asymptote there. There'd be another vertical asymptote here where a point doesn't exist. And we could draw other periods of the tangent graph. Because again, the tangent graph, just like sine and cosine, just kind of repeats itself over and over and